we're going to plug in 4 first. We're going to find out as x goes to 4 what this function equals. And we get negative 8 over 0 plus 1 over 0. Now this is weird. When this happens, we have an undefined number at negative 8 over 0. That's undefined, and we're adding to it another undefined number. Well, even though this does not look like our typical indeterminate form, usually we end up seeing this 0 over 0. Well, this is also an indeterminate form over here. So basically, when you see this, when you get a number over 0 plus another number over 0, you want to get a common denominator and get these fractions together and then try and take the limit. So when you see this happen, a number over 0 plus another number over 0, it's really hard to tell what's going on that function there. I mean, we know right away that it's undefined because you can't divide by 0. So the function's undefined, but just because a function's undefined doesn't mean it's not approaching something. And that's what the limit wants to know. What numbers are getting close to? Because it could look like this. It could just have a hole or something. So it could be approaching some point and just have no point there. And that's what happens with most of our limits. So we need to get a common denominator and then see what's going to happen. So for that, we're going to take the limit as x goes to 4. Now, x squared minus 16 factors into x plus 4 times x minus 4. Okay, so over here we have to multiply this x minus 4 times an x plus 4 over x plus 4. So like this. We're multiplying by x plus 4 over x plus 4. And that's going to allow us to put these fractions together. So this is going to end up being the limit as x goes to 4 of negative 8 plus x plus 4, we're adding this quantity here, over their common denominator, which was x plus 4 times x minus 4. So all I got to do is simplify that numerator. We're still taking the limit, so I still want to plug in, but look what happens now. Now we've got it to be one big fraction, and look what happens. Now when you plug in the number we're headed towards, 4, if you plug 4 into here, you're going to get 0 over 0, that indeterminate form again. So even though this doesn't look like it at first, when you put it together with common denominators, it really is the indeterminate form, which means there could be a hole at 4, there could be an asymptote at 4, we don't know. There could be all kinds of crazy stuff going on. So we just simplify down until we can cancel out that x minus 4 factor. Well, the top just simplifies into x minus 4. And the denominator is still x plus 4 times x minus 4, and you can see here that these x minus 4's cancel out, which means the function that we're dealing with is the same exact thing as its simplified version, which is just 1 over x plus 4. They're the same exact function everywhere except for at 4, because at 4 this function's undefined. We got an undefined number, but at 4 this function equals 1/8. Okay, it's continuous. And since it's continuous, the limit as x goes to 4 is just whatever it equals at 4, which is 1/8. And since this, I've said this several times now, but I'll repeat myself, since this function here we started with is the same thing as this function here except for 1 point, then they have to have the same limits. And since this limit is 1/8, then the original limit must also be 1/8. So that's the answer, 1/8.